Hello everyone. In today's class we're talking about projectile motion. Now, the way the class will move is we first talk about what a projectile is, then we define what a projectile motion is, and then we talk about the certain parameters that are very important in projectile motions. Certain parameters that more like define what a projectile motion is. And then we talk about the different cases of projectile motion that we have. And then from there I will then talk about some major highlights, then highlight some major aspect of projectile that you should not forget when you are going for your exams or when you are trying to solve questions on projectile. So without wasting too much of our time, let's start with what a projectile is. Now, a projectile is any object thrown into space upon which the only active force is gravity. So an example of a projectile motion is like when you throw a ball forward. Notice that the way the ball moves is, when you throw a ball inclined at an angle to the horizontal, like when you throw it up, as if you are throwing it upwards. Notice that the ball more like follows a parabola pathway. A parabola pathway is something like this. Something like this. So this is your horizontal plane. So you have the ball moving like this. It doesn't actually have to be a ball. It can be anything actually. It can be a rocket. So far the stuff is being thrown inclined at an angle greater than 90. Now, although in some cases of projectile motion we actually have those not inclined at 90 degree. But basically, if the object is thrown upwards and the only force acting on it is that of gravity, and now for a projectile motion you have two components. So far, since the surface is falling in the horizontal plane, now you have two components of the velocity, since the velocity is at an angle. So you have the horizontal velocity, and then you have the vertical velocity. Now, I don't really say velocity per se, but it's best for me to just use velocity so I will be able to understand it, even though we have acceleration and the rest. Now, for the velocity with which you are throwing the ball, since the velocity with which you are throwing the ball is inclined at an angle, so it will have two components. So far the angle is less than 90, it will have two components. Now the first component is the horizontal velocity. Now let's say you have this is the angle theta. Now you're throwing the ball up with a particular velocity u. So now you can resolve this velocity into two components now because it's inclined at an angle. And you use your saut car you use your saut car tour, but then in this case you mostly use saut and car. Now you identify what your opposite is, you identify what your hypotenuse is, you identify what your adjacent is. So the best thing for you to do is complete this diagram so that you have what's it called, so you are going to have a triangle. So let's complete this diagram. We have a triangle now. So let me extract that triangle out. So this is your u. This is your initial velocity which you are throwing the ball. Then you have your angle of inclination. Now the side facing your angle of inclination will be your opposite, while the side adjacent to the angle of inclination is your adjacent, while your u itself, your velocity in this particular case, because you can twist it, in this particular case is your hypotenuse, although most times your u is always your initial velocity that you are given is mostly always the hypotenuse. Now we have this. Now don't forget that the vertical plane represents y plane, while the horizontal plane represents x plane. So that means this is your adjacent, which is on the horizontal plane, will be represented with ux, while the opposite, which is on the y-axis, will be what? Your uy. So now to calculate, to to calculate your UI, which is your vertical component, your UI is opposite. You are given your hypotenuse, which is your U. Which of this between this or this actually align with this O and H? That's what your so. So you have what? You have sine theta equals, your opposite is what? UI. Your hypotenuse is what? Your U. So making UI for the formula, you have what? Your UI to be equal to U sine theta. Now I always tend not to like waste too much time on this. You have this. You should definitely know that your UX will be the opposite of your UI. So if you have your UI to be U sine theta, your UX will be U cos theta. If you have your UI to be U cos theta, your UX will be U cos sine theta. So as not to waste too much of your time in the exam module. So once you're able to determine what your UI is, you know that your UX will be what? The opposite of that, which is UX equals U cos theta. So those are the what? Your horizontal component, and then what? Your vertical component. So you have those two. Now another major important thing you should take note about your projectile motion is the fact that your projectile motion, as I said, that you have two components, horizontal and vertical, since the surface is declined at an angle. Your horizontal, you also have acceleration. Now your horizontal acceleration is 0 because the object is moving what? Forward, and there is no acceleration whatsoever. Nothing is stopping it. Nothing is reducing the speed. Nothing is making it to actually accelerate. So your horizontal acceleration for your projectile motion is 0. So AX is 0. Now, why your vertical acceleration, that's AY, that's vertical, this, your AY is what? Acceleration to what? Gravity. Now it can either be plus G or minus G, depending on the point that the object is in at that during the whole journey. So if the object is within this, is here, let me use a different color. If the object is around here, now you have two parts. You can split this into two parts, when the stop is going up and when the stop is coming down. So this part now is, in this particular part, your G will be negative, your acceleration will be negative, negative Gy, because the object is going upwards, it is going against gravity. So it will be what? Minus G here. So your AY in this case will be what? Minus G. Now from this point downwards, your AY will be positive because it's going what? Downwards in the same direction as what? As gravity. So your AY in this place will be plus G, and you know your G to be what? 10 ms raised to power minus 2, or you can also say like 9.81. So now that's established. So just to do a quick recap, for your projectile motion, undergoing projectile motion, we have two components, horizontal and vertical. Now for your horizontal velocity, to calculate your horizontal velocity and your vertical velocity, you're going to use your initial velocity that you are given, and you're going to use the angle of inclination that you are given. Now take note that the angle of inclination might not be with the horizontal, it might be with the vertical. It might be with the vertical component. So if it's with the vertical component, it becomes opposite of that. But then the most important is for you to actually identify how you are going to know your opposite, how you are going to identify opposite adjacent in a triangle. So once you're able to do that, you won't have any issue with knowing or determining how you are going to calculate your horizontal component or your vertical component, whether the angle of inclination is with the horizontal or with the vertical. So to calculate your horizontal component and your horizontal velocity and vertical velocity, you're going to use your normal SOHCAHTOA. You identify which is your opposite, you identify which is your hypotenuse, you identify which is your adjacent. So with that, you can calculate your y, which is your vertical velocity, and then you can calculate your ux, which is your horizontal velocity. Now, aside from that, I said that your acceleration, your horizontal acceleration, since you have different types of velocity, horizontal and vertical, so that means you also have their respective acceleration as well. Your horizontal acceleration is 0 because the velocity of the object remains constant. The horizontal velocity of the object remains constant all through the journey. While your vertical velocity is usually equal in magnitude to acceleration due to gravity, but then just that the direction changes along the line. Going upwards from this place, for the first aspect, the acceleration due to gravity, the vertical acceleration is what? Is minus g. While for the second aspect, the vertical acceleration here the vertical acceleration is plus g, is plus acceleration due to gravity. So with that said, now let's now go back to the outline. So you already understand what a projectile is. The projectile is basically just the object that follows a parabola pathway, that follows the trajectory of a parabola pathway. Now, in projectile motion, when an object is thrown obliquely near the Earth's surface, it moves along a curved path. As I said before, that's the parabola pathway towards the center of the Earth. Now, the path of such particle is called the projectile, and the motion is called projectile motion. Now, as I said before, that you have two different components, the horizontal and then the vertical. I said before that the horizontal is the x-axis, and then the vertical is the y-axis. I already said all this, that the acceleration in the horizontal plane is constant, as well as the vertical velocity is also constant. So the acceleration in the horizontal pathway is 0, while the horizontal velocity is constant all through. And don't forget from our previous class, or when we did motion, that I said that if the velocity is not changing, the acceleration will be what? 0. But then in order for there to be acceleration, the velocity must be what? Changing, because our acceleration is what? Changing velocity per time. So if there is no change in velocity, there can never be acceleration. Okay, so this is basically what I've already explained before, where you have your different horizontal component and vertical component. So let me go back here. I want to more like emphasize on something. Now you have this. As I said before, that you can divide this parabola pathway into two. You have the first journey. We call this the first journey. And we call this the second journey. Now the first journey is where the object is going upwards, while the second journey is when the object is what's coming down. Don't forget that all along the journey, the object still keeps moving forward. That's constant. This is one of the reasons why we have what? Constant horizontal velocity. Now, all along the journey, the body has two components. It has two types of velocity, the horizontal and the vertical. But then on getting to this point, this peak, this is referred to as the distance from here to here. Let me use a different color. From here to here is the maximum height. And at the maximum height, take note of all this. At maximum height, horizontal velocity remains the same, is constant. That's ux is constant, remains the same, while vertical velocity becomes plus g. Take note, it does not become minus g, it becomes plus g. It does not become 0 as well too. The velocity, the acceleration is never 0. The only thing that happens to the acceleration is it just changes. Whereas the acceleration now, the horizontal acceleration at maximum height is c0, while the vertical acceleration, what am I saying? Oh my god, what am I saying? Okay, let's go back. Now, the horizontal velocity at maximum height is still constant, constant k, while your vertical velocity becomes 0 at maximum height. Now let's not talk about the acceleration. Your horizontal acceleration still remains 0, while your vertical acceleration changes from minus g to plus g. So as I said before, that all through this journey here, the vertical acceleration was minus g because the object is what's moving up against gravity, while all through this journey it becomes plus g. So the point in which the minus g changes to plus g is what is at the maximum height here. So take note of all these values here. At maximum height, these are the things you have, because you might be asked a question like that, okay, at maximum height, which of the following is correct and all. So take note that at maximum height, your horizontal velocity remains the same, is constant. Your vertical velocity becomes 0. Your horizontal acceleration still remains 0, while your vertical acceleration changes to what? To plus g. So take note. So now we talk about so think of this. So when you try to like derive the formula, you'll be able to like flow along. Now with that said, now let's talk about the range. Now the range is the horizontal distance. Oh, I forgot to mention that your maximum height is what is the vertical distance, is like the maximum vertical distance. The height is like the vertical distance, so maximum height is like maximum vertical distance, while your range is the horizontal distance from the point of what throwing the ball upwards to the point of what the ball actually reaching the ground. So from here to here now is your what is your range. Your range is represented with what? With r. So with that said, and your range does not really have much. It's just like your height is a function of your vertical. It's more like is a function of your vertical component, since your height is the vertical distance. So anytime you are trying to calculate your vertical, or you're trying to derive the formula for calculating your maximum height or height at all, you have to use what? Your vertical component. While anytime you're trying to calculate your horizontal, your range, which is your horizontal distance, you're going to use what? Horizontal components. Now take note that time itself does not have, is neither vertical component or horizontal component, is both. So I'm just trying to just point that out. So when we're trying to derive the formula, it makes more sense. So that's what I wanted to point out. So let's go back now. So we already talked about all this. Oh yeah, I forgot to mention this as well. Now, so all throughout this journey, the vertical velocity for this first journey, the vertical velocity at this point, let me use a different color. Now at this point, the vertical velocity is maximum, while at this point the vertical velocity is 0, is minimum, is least, while at this point also the vertical velocity is still maximum. So at maximum height, the vertical velocity is 0, while at the starting point or at the end point, the vertical velocity is maximum. take note of that. Why the horizontal velocity remains constant all through. So sometimes you have something like this there. So this will be what? Your u y, your u x, your u x, your u y, like all through, like that. Okay. Now, to derive the formula for calculating your projectile motion, you're going to use, since we are saying that the body is following, is under gravity, and don't forget that under gravity you have what? Constant acceleration, and you use equation for uniform motion when the acceleration is what? Is constant. If the acceleration is changing, you cannot, if the acceleration is changing or the acceleration is zero, you cannot use equation for uniform motion. Just take note of that. So since the body is under gravity, which is constant acceleration, so we can use equation of uniform motion to actually like derive some of the formulas that we need. Okay, so these are some of the formulas we most likely like be using to actually derive these other formulas. So now let's start with, so now we are jumping to we're not like jumping, we are moving to some of the terms that we should actually like take note of when we are talking about projectile motion. I already mentioned some of them. Like we have our range, which is everything we have our height, or in this case maximum height, and then we have the time also. Now in this, since I said we have two journeys, the first journey and the second journey, the first journey and second journey, so that means we have two different times, time to complete the first journey and time to complete the second journey. Take note that the time required to complete the first journey is always equal to the time required to complete the second journey. So if this is T1 for the first journey, then this is T2 for the second journey. So T1 is equal to T2. So now the total time to complete the entire journey from here to here, let me something. Okay, so from here to here, from here downwards, will be total time of flight, which is T1 plus T2, which can also be what? 2T1, since T1 and T2 is the same, are the same. Okay. Okay. So now let's talk about the time of flight. And then for that I still need the diagram. So let me draw this again. We have our angle theta. So what are few things we need? Since we have all these now, we already know that our horizontal velocity ux will be u cos theta. Our vertical velocity will be u sin theta. Now we know that our acceleration for the first journey, at least, let's say a1 will be equals to minus g. That's for the first journey, and then acceleration for the second journey will be plus g. What other thing do we need? That's all. So now let's start with total time of flight. Don't forget that I told you that for this first journey we have T1, for this second journey we have T2. And don't forget that So let's start with T1 because don't let us complicate it for ourselves. Let's start with T1. So let's say we are trying to calculate the time for this first journey now. We know that what we'll be using is this. And don't forget that I know that anytime you're trying to calculate any component at all, if it is a vertical component, you use a vertical component. If it's horizontal component, you use horizontal. But whereas time can either be the horizontal or the vertical component. So it does not really have a particular component per se. So you can use time for either one of them. So if you're trying to calculate time, you can either use the horizontal component or the vertical component. But in this case, since we have the vertical component to be more complete, so we use the vertical component. Don't forget that I told you that the final velocity at this point for the final vertical velocity at this maximum height is 0. So now we have most for the first journey, we have our initial vertical velocity to be u sine theta. We have our final vertical velocity to be equals to 0. We have our acceleration to be minus 1. That's for the first journey, minus g. And then we have, what else do we have? Then we are looking for what? T1 for the first journey. We're looking for T1. Now, which equation of motion are we going to use? We have u, we have v, we have a, we have t. The equation we are going to use will be what? V equals what? U plus what? Plus at. Slotting all your values, you have what? Your v to be what? 0 from here, vy. Then you have your u to be what? U sine theta. And then plus what? Your a, your acceleration, which is what? Minus g times what? Times what? Times your t1. So you are going to have what? Making T1, so the formula, you are going to have T1 equals U sine theta all over G. When you do the maths, you are going to get this. So that means your T1 is equal to U sine theta over G. And don't forget that I told you that the T1 is equal to what? T2. And the total time of flight is what? T1 plus T2. Or it can also be what? 2T1 or 2T2. So that means you can say what? 2T1. So total time of flight is what? 2T1, which is what? 2 times what? U sine theta over G. So your formula for calculating total time of flight, which is T, is equal to equals 2u sine theta over G. So that's the formula for calculating what your total time of flight. Take note of that. So you've understood how we actually got that. So we can also use the T2 for the second journey. So you can attempt that yourself. The reason that will just be changing that, okay, your acceleration now becomes what? Plus G. Now your initial vertical U will now be, if you are using this second journey, your initial vertical U will now be what? 0, and then your final vertical U will be what? U sine theta as well. So you can try and do that yourself. So that's for how you calculate the time along for the first journey, same thing for the second journey, and then for the total time of flight. So that's how they got this. Now for the horizontal range, so I'm going to leave. Okay, there are a few things that will more like highlight out. To know our total time of flight, so now our total time of flight, T, to be equal to 2u sine theta over G. And then our range, since we're having an horizontal, we're having a horizontal vertical component. So to calculate our range is like the horizontal distance. So I'm going to use horizontal components, as I said, which is what? Your u cos theta. So don't forget that your speed is equal to what? Distance over time. or your velocity is equal to displacement over time. And that means your distance now in this case will be what? V times t. So that like your velocity times time. So that means your horizontal range now will be what? Your velocity, which is what? U. So I said that is horizontal something. You have to use horizontal something. U cos theta times what? Your t. Now the t you are going to use now will be what? 2u sin theta, because your range is from here to here. And your total time of flight is also what? From here to here. Also from here to this point. As you have to calculate half of the range now. So you are going to use just t1. So you use u sin theta over g instead of 2u sin theta over g. But since you are looking for the total range, so that will be what? U cos theta times 2u sin theta over g. Now, in this case, I'm not going to get what? You're going to get 2u square sine cos theta all over g. Now, take note that, how will I write it? 2 sine cos theta is equal to sine 2 theta. So that means you're going to replace that in this equation so that you have your range to now be equal to u sine 2 theta all over g to be what? Your formula for calculating what? Your range, which is what we have here. Oh yeah, we still have u square. Sorry. Basically, what we did here is what? 2 sine cos theta, which is equal to sine 2 theta. Don't forget here that you have u times u to be what? U squared. So you have how to be equal to what? U squared sine 2 theta over g. I hope you understand that. Now moving forward to maximum height. This might be a little bit tricky, but then it's not tricky per se. Not tricky. I think I just like using the word tricky. Now, for the maximum height is more like the distance from this point. Let me use a different color. Distance from this point to this point. And the way you can calculate that is by using the vertical component for either the first journey or the second journey. So let's use the first journey to make life easy for ourselves. So now for that, we have acceleration. We have acceleration. We have initial u, we have final u to be equal to 0. We have basically all this. So, and we already calculated what? T1 already. So how are you going to calculate the s now, which is the vertical distance? So we are going to use what? S equals ut plus half gt squared. So you know your u, your initial u. So we are looking for s now. So our initial u, so we have let me clear out some space. Let me just clear up the entire stuff. So we have s equals ut plus half gt squared, or half at squared. Let's use half at squared. So now we are looking for our s now. S equals to, now our u is what? Since we are using the vertical component, u is what? U sine theta. Then our t, we are going to use t1 for the first journey. T1 for the first journey. and you have T2 here. So you're going to use T1. And when you calculate at T1, oh, these things are too big. Okay, S equals to U, which is what? U sine theta, times our T. Our T is what? U sine theta over G. Now, plus half times minus G. Then our T is what? U sine theta all over G. Don't forget everything what? Squared. So by the time you expatiate everything, you simplify it, you're going to have U square sine square theta over G minus G times half. That will be what? Minus G, then everything times U square sine square theta all over G squared. 1G will cancel 1G, such that you have what? U square sine square theta all over G minus U square sine square, oh, you have 2 all over 2 sine square theta all over 2G. So you do the math, you are going to have what? Your S now to be equal to U square sine square theta all over 2G. So you can just change that S to what? To your maximum height, to be equal to what? U square sine square theta all over 2G. So that's what you use to calculate what? Your maximum height. Your maximum height. I hope you understand. I hope you get that. So moving forward now. So now this particular equation might not really be necessary for you guys, but then I would just like to just add it. So just take note of this formula, because if I was to derive this formula, it's like a very, very long process. I don't think they will ask you, but then it's very good to actually have this base knowledge like ahead of your post-UTME time. So now this is the formula. Formula is x tan theta minus gx squared all over 2u cos square theta. Now there are some times that you might be asked, you won't be asked, but then there are some questions that actually involve you determining the position of the object along the journey. What that means is that now you have this projectile motion. Now you have this object following parabola pathway in this particular motion. You might be asked to determine, okay, at what point will the object be after so seconds. So probably after that seconds, the object might be here. You might be required to determine the velocity at that point, or the or the acceleration, or the velocity at that point, whether the vertical velocity or the horizontal velocity. So you are going to need this particular formula to do that. But then let's just reserve this for your ahead of your post-UTME. But then just for knowledge purposes, just take note of this formula: x tan theta minus gx square minus 2u square cos square theta. Just take note of that ahead of your post-UTME. So that's all for projectile motion. So see you guys in the next class.